Previously, we've learned how to send requests with the prompt hello to OpenAI using curl command line. We did it at the terminal, but now we'd like to do that in Emacs with an Emacs Lisp program, and we want to execute the curl command asynchronously. We can do that with the function makeProcess, and the goal of this lesson is to learn the basics of makeProcess function. The first thing we are going to do is to execute the following command, echo foo bar base, with the function makeProcess. So let's go into the file chatgpt.l where we are going to write this code. So make process, we have that. Let's have a look on the documentation of that function, which states that makeProcess starts a program in a subprocess and it returns the process object for it. We are going to use the argument name, buffer, and common specified as keyword arguments. So let's go back to that file and start doing that. So the name, we are going to call it foo name. If a process with that name already exists, makeProcess will make that name unique. Buffer, this is the buffer in which the standard output of our command will go. So let's call that buffer. So if foo buffer doesn't exist, it will be created, and if it exists with that name, the content of the standard output will be appended to that buffer. And now the command that we want to write, we have to pass it as a list with the name of the command and the argument after. So we write a list. In our case, we have echo foo bar and base, and now we are going to evaluate that whole expression and jump after into the buffer foo buff to see what we have. So we evaluate. And now let's go into the buffer foo buff, and we see that we have foo bar base at the top, which is the standard output of our command, and this line process foo name finished has been added by the Sentinel, and we are going to talk about that later. In this section, we are going to learn about some of the functions that we can apply to the process object returned by makeProcess function. So to do that, we can set the variable fooproc to the process returned by makeProcess, which runs the command echo foo bar base. So we evaluate that whole expression, and now we are going to check if the variable fooproc is really a process. So this is the case, and now we are going to look at three functions that we are going to use later in that course. So if we want the name of a process, we can write this and use the function process name. So we get foo name. Now if we want the buffer associated with that process where the output goes, we can use the function process buffer, and we get that buffer foo buff. And finally, we may want to check if the process is alive. So to do that, we have the function process live -p foo proc, and as our process is terminated now, if we evaluate that expression, we get nil. What if we want to run a program that contains a pipe like this one, slip2 pipe echo foo, which prints out foo and wait 2 seconds before returning using makeProcess? So we cannot do that as we did before with the list describing the command, with echo being the program file and after foo bar being the argument. because the pipe is a syntax element of the command interpreter, so we cannot use it as an argument, and the command keyword in make process expect only one program file, so we cannot have a sleep and echo. So how do we do that? We can remember that the command interpreter with the with a -c will consider everything after the -c, the next argument, as a command line. So if we do that, we are executing exactly the same command. So now we have a program file which is sh and two arguments, -c and the other argument. So now we can do something like that. So let's go back to chatgpt.l and we print that. Here we have a list, and now this is sh-c, and we want to give it the directly the command containing the pipe. So now we can evaluate that, and we are going to see it working as expected. And if we go to the buffer foo buff, we see it working. Finally, we are going to see how we can put the content of the process buffer into another buffer after the process has finished. We do that with Sentinel functions that are attached to the process we start. Here we attach that Sentinel function, lambda. This takes the first argument, which is the process, and an event, and a Sentinel function is executed whenever the process status changes. So right now we are going to see what we want. We want to see the value of the process and event argument. So we take this one, we go there, we pass that here, and now we are going to evaluate that whole expression, which is going to run the command sleep1 pipe echo foo, and when the process finishes, we'll execute that Sentinel function, and we'll see in the echo area the process foo name and the event, which is the string finish with a new line. So fine. What kind of event we can have? One other event that we can look at is when we kill the process. So we are going to kill the process, so we passed that, so we execute the same function that run the process and the command sleep1 echo foo, and we are going to kill it right away. So we evaluate this, and we see in the echo area that we have again the Sentinel that has been executed, and that print the process foo name, and also the event, which is this time killed with a new line. Now let's modify the Sentinel function to distinguish between the case where the process finishes correctly and where the process, for instance, has been killed. So we can write that like that. If not string the event, if the event is not finished, okay, so we are going to print out in the echo area error. Okay, we have that, and if it has finished correctly, we just print okay. So if we evaluate that expression, which is enclosed by a call to the kill process, we should see error in the echo area. This is what we see, because we are killing the process just after we start it. And now if we remove the call to kill process and we evaluate again, after 1 second we see in the echo area, okay, so we've distinguished between two kinds of event, finished and the other. Now we are going to modify the Sentinel function in order to take the content of the process buffer and print it out in the echo area. But previously we go into the foo-buff and we see a bunch of foos that have been appended to that buffer because we've called make process with that buffer as a process buffer several times. So we kill that buffer and we are going to do what we said. So now, okay, so we remove that. In a let binding, we are going to bind stdout, the variable stdout, to something that is in the current buffer, which is going to be the process buffer. So to have that buffer, we can use the function process buffer that we've seen previously, that will return the buffer attached to the process, which is passed as argument of the Sentinel. Now, with that buffer current, we are going to use the function buffer string, which takes the content of the buffer and return it as a string. So now, after that, in that let, the standard out is a string with the content of the process buffer, and now we can print it out in the echo area like that. Stdout, and we are going to evaluate that expression, which run the function make process, run the command sleep1 pipe echo foo, and when the process finishes correctly after 1 second, we will see in the echo area the string foo. Finally, we're going to put the content of the process buffer in another buffer called bar instead of printed out in the echo area. But before we do that, we go back again in the foo-buff process buffer, we kill it again, and now we modify that. So we want the current buffer to be a new buffer, get buffer create. So if it exists, it will take it, and if it doesn't exist, it will create one. So foo bar, and when that buffer is current, we want to insert in it the content of the process buffer, which is now in the variable standard stdout. So let's evaluate that expression. Now we switch to the buffer bar, and we see that we've printed that, we've inserted in that buffer the content of the process buffer. That's it for the basics of the make process function. Next time, we will apply this knowledge to send a request to OpenAI from Emacs Lisp.